All right, so 3.3, day 2, looking at examples 4 through 6 here. Talk about what a linear function is in part 1. That was a function that forms a straight line. It's got a constant rate of change, right? We talked about that stuff. So today we're looking at how do we graph it? How do we determine whether it looks like this one with the dots or this one where it's connected? And these are two different types of linear functions. We've got discrete and we've got continuous. The discrete graph, you'll notice, is just dots here. Okay, a discrete graph is just dots. And we'll talk about why that is in a second. But discrete is just dots, D and D, right? Discrete dots. Whereas a continuous one, we say is connected. Okay, so C and C, connected, continuous. So the reason why these are just dots versus connected, a discrete graph is one where our domain is just going to be a list of numbers. Okay, remember our domain is our possible x values. Possible x values here. So our possible x values are just a list of specific numbers. Maybe something like this, right? Maybe our domain is 1, 2, 3, 4, 5. Okay, just those numbers. Whereas over here, we're talking about a continuous graph. Because it's connected, that means I can have data, I can have values anywhere between here and here. So my x value could be anything. My domain could be anything between here and here. So we're going to have a compound inequality for this one. It could be something like this, right? Where x is anywhere between 1 and 10. This is 1 and this is 10. Okay, so our continuous graph has a domain that's a compound inequality. Okay, continuous, connected, compound, I'll start with those C's there. Whereas our discrete graph is just the list of numbers, okay? So this is specific numbers. This is specific numbers, whereas this is a range of numbers. A range or an interval of numbers. Okay, and that's the big difference here, because the interval of numbers, that range of numbers, that tells me I can have any number that's in between there. I could have 1.73. I could have 4.5. I could have 5.02, right? I could have any x value between 1 and 10. Whereas here, I can't have those decimals. I can only have those specific points where those are. And so what we're going to see today is we're going to see word problem situations where we have to determine, is it best described by a discrete graph or a continuous graph? Okay, so that is what we're looking at today, is what's the difference there and when are we going to use each one of those? So if we take a look at the book here, take a look at, let's find it. Yeah, we'll look at this one first. There's just an example of continuous and discrete. But we're going to look at this example. Okay, so this example says the linear function, and then they give us an equation. Y is equal to 15.95x represents the cost Y of X tickets for a museum. Each customer can buy a maximum of 4 tickets. Find the domain. Is the domain discrete or continuous? Now, the thing to keep in mind here is it has to be the X values that we're looking at. We don't care about what happens to the Y right now. We care about what are the possible X values that we have. And X represents the number of tickets here. Okay, X represents the number of tickets. So we can buy 0 tickets. We could buy 1, 2, 3, up to 4 tickets. But you got to think to yourself, can I buy those decimal amount of tickets? Can I have those values in between? Can I buy 1.7 tickets? I can't buy 1.73 tickets, right? So this is a discrete graph here. I know it says discrete up here, so we knew that already. But this is discrete because we can only buy a certain number of tickets. It's tickets because of the X. I had some people in class today talking about how we could only pay a certain amount of money. We don't care about the Y. We care about the X. X is the number of tickets. I can only buy a certain number of tickets. That's why it's discrete. So our domain here, we know it's discrete, but our domain would be the possible X values. So I can buy 0 tickets, 1, 2, 3, or 4 tickets. That's our domain. When it asks us to graph using the domain, well, we know if it's a graph and it's discrete, we know it's just going to be those dots. It's going to be those dots at 0, 1, 2, 3, and 4 along our graph here. So 0, 1, 2, 3, and 4. So then we have to look at the equation for this graph. If I'm buying 0 tickets, of course, I'm going to pay $0. But if I'm buying 1 ticket, I'm going to pay $15.95. So $15.95, I'm going to pay 1 ticket, right? And that's going to continue on. I don't know what those exact numbers are, but that's going to continue on, and it's going to look something like that. Discrete graph, right? Just the dots based off of the possible domain that we could have. So our graph is going to look like that with just the dots, because we can't have the value in between, right? I can't have a data point at 1.6 tickets because that's impossible. I can't do that, okay? Let's look at the other side of things with a continuous example. So now our continuous example here, talking about an ant eater eating a whole bunch of insects, 35,000 a day. And so now we know this is going to be continuous because it says so up at the top. But it's continuous because got a little glare going on there. Let's see if I can. I think we can see the important part there. It's continuous because of the x value. The x values are independent variable. It's what we are in control of. In this situation, we are in control of the number of days we are talking about. If we were to create an equation here, this would be y is equal to 35,000 x, x being the number of days. So since we're talking about a number of days that we are measuring how many insects the anteater has eaten, we actually can do 1.5 days. We can measure after 1 3/4 days or 5 1/3 days, right? I can measure all of those values in between. That's why this is going to be continuous, because I can measure at any point along the route there. Right? In terms of what our domain is, we got to think about what's the smallest, what's the starting point. The starting point is 0 days. Okay? I can't talk about negative days. I'm not going to talk about how many insects the anteater ate in -5 days. That doesn't make sense. So I'm starting at 0, and I'm saying that x can be anything greater than or equal to that. And that's it. Right there, that's our domain, because we don't have an ending point here. It doesn't tell us that the anteater is going to live for 100 days or 10,000 days or however long an anteater lives. All we know is that we're starting at 0 and we're going on from there. So in terms of our graph then, we go to graph this, yeah, 0 days, 0 insects. But then after 1 day, I got 35,000 insects. So I put a dot there. This is continuous, right? It's connected. So I'm going to connect those. And on big ideas, all you have to do is put those 2 points, and that's what's going to happen. They're going to draw that line for you, right? And we could continue and put more points on there, but all those points are going to be on that line still. If I plug in a 5 here, and I get some big number of insects, and I graph that, yeah, it's going to be on that same line. So we really just need those 2 points connected, and we've got that continuous graph. Continuous because I can measure my x's as decimals, as fractions, not just specific numbers. Okay? So that is a continuous graph. That's the main part of what we're talking about. In class, we also mentioned something like this, and just coming up with your own situation where something might be discrete or something might be continuous. But this could be something, let's see, we're draining a bathtub for 6 hours. Started with 60 gallons, I'm draining it for 6 hours, right? That is continuous, because I can measure how much water is left in the tub after 3.5 hours or after 4.17 hours, right? I can measure that. That's continuous. I can have those decimals. Whereas over here, this might be, I have $60 and I'm paying $10 per candy bar, a giant candy bar. I just made that up. right? But if I'm paying $10 per, I can only buy whole numbers of those candy bars. Yes, I can eat, right? I can eat 1.5. I can't buy 1.5. So we're looking at purchasing some number that's going to give me that discrete graph with those dots there. Okay, so that's what we're looking at: discrete versus continuous. We got to know the difference. We got to be able to find the domain and then graph it accordingly. Okay, and that's what there is. That's really all there is for day 2 here of 3.3.